This lesson is introducing the idea of a mole and molar mass. And to best display that is to use an analogy. Let's say, for example, we have 1 dozen donut holes. Most people are going to envision 12 donut holes. All right, and the next step to that is molar mass. In other words, we can almost call it, in this case, the dozen mass, okay? Dozen mass. And the reason I say the dozen mass is because the units we're measuring by is dozen. And the question is if I have a scale here, there's my scale with a number, and if I put a dozen donut holes on there, because it's a dozen mass, okay, here are my donut holes. There are the donut holes. And those are those little round pastries. If I have a dozen donut holes on the mass, they would weigh 12 grams. Okay, let's say each one weighs 1 gram. And because I have 12 of them, they weigh 12 grams. So what that means is that 1 dozen donut holes has a mass of 12 grams because on that scale I have 12 donuts, each weighing a gram apiece. So I think that's pretty straightforward. So now let's actually connect that to the idea of a mole. So instead now let's say I have 1 mole of carbon. All right, so you will remember, hopefully, that a mole means that you have 6.022, like 16th trillion atoms of carbon. It's not just a number by itself, okay? It is a quantity, just like a dozen is a quantity. So 1 mole of carbon is this many atoms of carbon. And now, let's envision again our scale. And on this scale, instead of putting 12 donut holes, I am putting this many atoms on top of it, okay? So I go dot, 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 dot. I'm going to do as many dots, a whole pile of them. There they are, the whole pile, that in the end I have 6.022 times 10 to the 23rd atoms on there. In other words, 16 trillion of some sort, 6 tillionth numbers of atoms of carbon are sitting on here, because that equals 1 mole. We call this the molar mass. Why? Because 1 mole of atoms is sitting on here. And remember, 1 mole of atoms is 6.22 times 10 to the 23rd individuals. And each of these, when you combine all of these atoms, the 1 whole mole in carbon, it just happens to be 12 grams. Because carbon has a molar mass of 12 grams. Where is it that I found this? I found this at the periodic table. And yes, someone actually tested this out and did the calculations to get these numbers, believe it or not. And the cool thing is that they just so happen to correlate with the atomic mass. Quite phenomenal when you think about it. That is molar mass. So now comes, how do you calculate the molar mass? And the important part is getting a conceptual understanding of what molar mass is, but how do we calculate it? So let's say, for example, we know that 1 mole of hydrogen is 6.022 times 10 to the 23rd atoms of hydrogen. That's how many I have. And if I place them on that scale, here's my little scale. If I place all those on the scale and just had hydrogens, they would weigh 1 gram. Okay, so hydrogen is not a very heavy atom, and when you have lots and lots of them, they don't make a whole lot of mass. So the molar mass of hydrogen, oops, is 1 gram. So we can say 1 mole hydrogen equals 1 gram of hydrogen. So now let's try one more. Let's do 1 mole of oxygen. 1 mole of oxygen, remember, it's a quantity, the mole. That means I am telling you that I have 6.02 times 10 to the 23rd atoms of oxygen. And when I place those atoms of oxygen, all of those atoms on my scale, if I place 6.022 times 10 to the 23rd atoms on that scale, you have 16 grams. And all of you guys actually did this. Remember, you put aluminum cans on the scale to measure 1 mole. And it happens to be about 2 aluminum cans make up about 6.022 times 10 to the 23rd. So sometimes these come in molecules. So in this case, let's say I have 1 mole of water. In this case, you notice the subscript 2. So first of all, we know that we have 2 different elements, and we have that subscript 2. If I were to break it down into the parts, just like that analogy I made of the Oreo cookie, we have double the amount, or double the moles of hydrogen than we do oxygen. We only have 1 mole of oxygen for every 2 moles of hydrogen. We know that that means that if we have double the moles of hydrogen, we need to have double the atoms. So that's 2 times 6.022 times 10 to the 23rd, atoms of hydrogen. And this here is just 1 mole, so that's 6.022 times 10 to the 23rd atoms of oxygen. Okay, so looking at our numbers here, we know that 1 mole of hydrogen equals 1 gram. So what would 2 moles of hydrogen equal? Well, it should have double that mass. So we should have 2 grams. 1 mole of oxygen equals 16 grams. And if I add them all together, I have 18 grams. That means 1 mole of water, which is 6.022 times 10 to the 23rd molecules of water. If I place all of those on my measuring scale, they would work out to be 18 grams. So let's move on to one other key idea, and that is, how do you name these chemicals? So first of all, if you have just an element by itself, you might have hydrogen, or you might have iron, you might have O2, you might have calcium. They're all by themselves. They're unique elements that aren't connected with any other elements. Single elements. When that's the case, we call them atoms. And you notice that I even call oxygen a single element because we treat it that way. It's diatomic, okay? And you have the same element. But in cases like this, where we have H2O, or we have C6H12O6, or we have, let's see, PO4, okay, phosphate. These are all combined together with different elements, so they are given a different name. In this case, all of these are nonmetals. Hydrogen is a nonmetal, oxygen is a nonmetal. Carbon, hydrogen, oxygen, all nonmetals. Phosphorus is a nonmetal, and so is oxygen. So these are nonmetals, and when you have elements that are nonmetals combined together, we call those molecules. So this would be 6.022 times 10 to the 23rd molecules of C6H12O6. This, on the other hand, would be 6.022 times 10 to the 23rd atoms of calcium. So we have to look at how we're going to describe them and describe them correctly with the right terminology. Let's say you have NaCl, or what else could there be? Aluminum oxide. You might have potassium chloride. The first ones you notice are metals. These are a metal. Aluminum is a metal. Potassium is a metal. And then the second one is a nonmetal. So in this case, we have a metal bonded with a nonmetal. And when that's the case, we call them formula units. So in this case, 1 mole of sodium chloride would be 6.022 times 10 to the 23rd formula units NaCl. The one last thing I want to talk about with doing molar mass is this, is that sometimes you get problems that are a little bit more complicated. Let's say you have aluminum nitrate, NO3 over 3. So I know that aluminum has a +3 charge, nitrate a -1. To even those out, I need to get 3 of them. So just so that you are clear, how would I break that down in terms of moles? I would have 1 mole of aluminum. This 3 applies to all of these in the parentheses. It does not apply to the aluminum. So in that case, I have 3 moles of nitrogen. And I have, in this case, 3 times 3, so 9 moles of oxygen. And then I find the molar mass to all of them, and I can add them up. So that's how I would break that down. And that ends our lesson on molar mass.